Hey guys, what's going on, man? Here is your test review. All right. For this first one right here, we have the difference of cubes at the top. So first of all, fake plug in. So -5 cube is 125. -125 plus 125 all over 0, 0 over 0. So we can't leave it like that. So what we're going to do is we're going to factor and simplify. So the limit as x goes to -5 of x plus 5 times x squared uh, minus 5x plus 25. That cancels out. And so you have the limit as x goes to -5 of x squared minus 5x plus 25. Plug in -5. You get 25 plus 10 plus 25, which is, I'm sorry, that would be 25. -5 times -5 is positive 25, so 75 right there. My bad. All right, right here. Again, fake plug-in. So you get the limit. Well, we'll for our fake plug-in. So just plug in. So 1 minus 0 all over 0 minus 1. You get 1 minus 0 is 1 over 0 minus 1, -1, -1. All right, right here for number 3. If you do fake plug-in, cosine of 0 squared all over 0, you see that cosine of 0 is 1. 1 squared is 1 over 0. This is undefined, which means there's a vertical asymptote present. All right, at x equals 0. So we know that the graph has to go up or down. All right, so you can literally t-chart this one. As I approach 0 from the left, so x, y, 0 from the left is undefined, so I'm coming from the left, so -2, -1. Well, here, let me pick unit circle values. That way we can use those. Power of 2, negative power of 4, and negative power of 6. So cosine of negative power of 2 is 0. So this is 0. Cosine of negative power of 4 is going to be, this will give you root 2 over 2, but it's over negative power of 4. So this whole thing is negative. Same thing right here. You plug in negative power of 6, you get root 3 over 3. Root 3 over 2, sorry, but it's squared. This is also squared. All over negative power of 6. This is still negative, but you can see as I come from the left, I'm going down to negative infinity. So I answer here the limit as x goes to 0 from the left of cosine squared x over x is negative infinity. One other thing I want to point out to you is that this is the same thing as this. All right. All right. So for this problem, I'm first going to start with getting common denominators. I think that's the easiest thing to do at the top. All right. Let me zoom in so I can. All right. I want common denominators at the top. So I need to put this radical down here. And if I do it down there, then I, of course, I have to do it at the top. So we end up with a limit as x goes to 0. And guys, fake plug-in didn't work. Let me start there. I always forget to do that just because I can tell at the gate, but you get 0 plus 1 is 1, so 1 over 1 minus 1 all over 0. And it becomes undefined. So it tells you have an asymptote there. All right. So now we got to see if they're both going in the same direction or not. But anyway, let's keep going. So common denominators, 1 minus the square root of x plus 1 divided by the square root of x plus 1 all over x. Which now you can really, if you understand keep, change, flip, then you know that this x, if you were to flip it, it would be this because you're dividing by a fraction. 1 times its top is just its top. And then the x will get multiplied to the radical. Like that. So we still, fake plug-in won't work because 0 right here will give us undefined. So we don't want that. So we're going to use the conjugate method. All right, it won't be one like this on your test where you got to use conjugate. There can be a radical. We got to common denominator. That's just algebra. But the conjugate method won't be on there. So let's just do it anyway. So I'm going to multiply both the top and the bottom by 1 minus the radical. Like that. And so the top, remember, I'm sorry, 1 plus the radical. Man, didn't catch that. So you got 1 times 1 is 1. 1 times the positive radical is the positive radical. 1 times the negative radical is the negative radical. Those are cancel out. And then you have negative radical times the negative radical, which is just the negative stuff underneath the radical. And then at the bottom, all right, now let's simplify some more. I'll distribute that negative 1 minus x minus 1 all over x, the radical, and then 1 plus the radical. Simplify even more. And I know, you're like, it's a long problem. Sort of, kind of. We're just doing all the steps. 1 minus 1 is 0, so you're left with negative x at the top. And at the bottom, you got x times the radical. Like so. Oh, by the way, let me save a step. That negative, that x and that x cancels. So I just have negative 1 all over this radical times 1 plus this radical. And then we'll simplify from there. So when we simplify, well, I'm not going to simplify, I'm just going to fake plug in now. So since I'm fake plug in, I don't need to rewrite the limit. So we get negative 1 over 0 plus 1 times 1 plus 0 plus 1. Negative 1 over square root of 1, 1 plus 1, or square root of 1. Negative 1 over 1 times 1 plus 1, negative 1 half. 1 plus 1 is 2 times 1. Whew, that got lengthy. All right, let's see here. Fake plug-in, negative 2 squared is 4 minus 4, negative 2, negative 8. Okay, so fake plug-in doesn't work, guys. It gives us 0, 0. So let's factor and simplify where we can. Negative 2. So we get x plus 2, x minus 2. All right. The difference of cubes, x plus 2 times x squared plus minus 2x plus 4. You'll notice right here, those cancel out. So now let's fake plug in now. So -2 minus 2 is -4. And -2 squared is 4. Plus 4 plus 4. All right, so we get -4 over 12, which is -1/3. This is just in behavior model, but because it goes to infinity, this is in behavior model. But before I move on from it, I do want to point out that you need to consider, because this is a product at the bottom, at some point, this x squared gets multiplied to that -x. All right. So my in behavior model is actually x over -x cubed. And since it's bottom heavy, I just didn't want you to look and go, oh, x squared, and say, oh, it's bottom heavy. Because if I did that, it's still bottom heavy. I don't want anybody to think this is the same. This is not the same. This is bottom heavy because those x's will get multiplied out, and that's really x cubed. So bottom heavy. When it's bottom heavy, y equals 0, or the limit equals 0. That's what the horizontal asymptote is. Make sure you understand that piece right there. That's multiplication, so that's really x cubed. All right. Number 7. I'm not gonna I'm gonna just write that out real quick because it's really not a lot to talk about with it. The graph looks like this. All right. There's a horizontal asymptote at y equals 0. All right. Exponential functions never cross the y-axis unless you turn it upside down, which means you did that. All right. The whole function will have to be negative. So, yeah, this is just something you gotta know. All right. Let me get to number 8. For number 8, if you did fake plug-in, you get 0 over 0. Because cosine, actually you get 1 over 0. 1 over 0. In a sense, because cosine of 0 is 1, so you end up with cosine of 4. And over 0, that's undefined. All right, so because it's undefined, you could easily check. This is limit from both sides. All right, so I'm just gonna check both sides real quick, just so you can see how it's done. So we're talking about 0, so -2, -1. Actually, pi halves, power 4, 0, power 4, and pi halves. I'll do that. So, cosine of pi halves would be cosine. So you have 4 pi over 2, -4 pi over 2. This is really cosine of 2 pi. Cosine of 2 pi is 1. So that's still negative. Cosine of negative pi over 4. So you get cosine of pi of 4, times negative pi over 4. Which is just cosine of pi. Cosine of pi is negative 1. And then cosine of 0 does not exist. Cosine of pi over 4 would just be cosine of pi, which is -1. And then cosine of pi over 2, same setup. You end up with 2 pi, which is 1 over pi over 2. All right, now what's my point in this? My point is, as I get closer from the left, negative is positive. So from the left, Um, well, you see this is oscillating on both sides, by the way. But the closer and closer it's oscillating. So the closer I get, guys, what actually happens is this side will go down, this side will go up. I'm just not picking close enough values. I could, but the point is it's oscillating and it's gonna go in opposite directions. All right, and just I know that because see right here, I'm the same distance, right? I'm pi halves. The magnitude is pi halves from both sides. So I'm pi halves to the left, pi halves to the right. They're opposite. All right, now I'm pi to the fourth. I'm pi to the fourth to the left, pi to the fourth to the right. All right, they're going opposite. So that means the closer I get is going to keep going opposite directions. So this limit does not exist because the left and the right, remember, this is both sides. This is both sides, so it's going to go in opposite directions. All right. That's the explanation on that one. Okay, number 9 right here. Number 9. Let's see, fake plug in, 1 over 0 won't work. So we got to do some simplifying. Again, in order to do this, you need common denominator. So multiply by 2 over here and x over here. So we have the limit as x goes to 0 of 2 over 2x minus 1x over 2x, all over 2x. Which really, hold on. Let's rewrite this. Let's go 2 minus x all over 2x, like that. Over 2x. And so if you remember what we talked about earlier, keep change flip, you end up with really the limit as x goes to 0 of 2 minus x over 4x squared. All right. When you keep change flip, you end up with 1 over 2x right there. So now when you do all your plugins, it's still so again the same scenario right here is undefined, right? 2 minus 0 is 2 over 0 is undefined. So that tells me that I'm going to go to my old T-chart method, all right, because 0 is undefined. So I'm going to check the left. From the left, so -2, if I plug in -2, 2 minus -2 is 0, so that's 0. Or 2 plus 2, sorry. 2 minus -2 is 2 plus 2, so 4 over 16, which of course we know that's 1/4. Now if you plug in -1, 2 plus 1 would be 3, and then -1 squared is 1 times 4 is 3/4. So we're getting bigger as we go this way. We're increasing towards infinity. On this side, if you plug in 1, 2 minus 1 is 1 over 4. You plug in 2, 2 minus 2 is 0. So it's just 0 at the top. But I'm still getting bigger. I'm going up to infinity. This side increases faster, but still I'm going to infinity. So this limit right here is infinity, guys, because on both sides, I don't have an exact idea what the graph looked like, but oops. This side is increasing faster. They're both going to infinity, and because the end behavior is the same, infinity would be our answer right here. Let's look at 10. For 10, we have the limit as x goes to -3. 2 of 3x squared minus 2x minus 8 all over 2 minus x. And so we probably need to factor this one. Let's see. Let's try fake plug in first. 2 minus 2. No, it won't work with that. All right, so let's factor both the top and the bottom. So 3 times 8, 3 times 8, -24. We'll factor 6 in, -6 and 4, or, yeah. So we get x minus 6, x plus 4, x minus 2, 3x plus 4 all over. And I'm going to factor out a negative at the bottom. So that becomes x minus 2. The reason I took that out is because I saw x minus 2 at the top, and we can make this bottom will look like the top. Just factor out a negative. Then the signs change. The x becomes positive, the 2 becomes a negative. Anyway, that cancels. So we're left with the limit as x goes to 2 of negative 3x plus 4. And so now when we plug in 2, we can plug in, now fake plug in. 3 times 2 is 6. 6 plus 4 is 10, but you got the negative out front, so negative 10. All right. All right, 11. Look, listen, I guarantee you're going to have a problem like this. Like, I guarantee it. All right. It's just variables, guys. It's just factor. As I go to b, so if you can't, you fake plug in b squared is b squared minus b squared is 0. And b minus b is 0, which is indeterminate. So we need to factor and simplify. If we go, so remember difference of squares. So x plus b, x minus b, all over x minus b. All right. Again, that x minus b cancels. The limit as x goes to 6 of x plus b. And when you fake plug in, oh, not 6. Why did I say 6? That's horrible. That should just be a b. You get b plus b, which equals 2b. All right, number 12. So we got to sketch this piecewise function. We got a slope of negative x and 5. That means negative 1. Negative 1, the y-intercept is 5. So we can start here. Slope is negative 1, so all the way to 3. 1, 2, 3, yeah, right here. So that is 5 minus x. And then we got this part of the graph when x is greater than 3. Not the best drawing right there, but anyway, I'm gonna use another color. I'll go red. So negative 3, if I plug it in, let me see. Negative 3 squared, negative 9, plus 18 minus 8. So negative 17 plus 8 is gonna be 1. Negative 18 plus 17, sorry. Negative 9, negative 8 is negative 17. 18 minus 17 is 1. So 3, 1. Boom, right there. All right. Then we go to the next. So like we got 4, negative 16, plus 24, minus 8. So negative 20. Oh, that's 0. 4, 0. And then 5, negative 25, plus 30, minus 8. All right. So now we're getting to the negative values. Because that's negative 33. So negative 33 plus 3 is negative 3. So we're like right here. And it just goes like this. So that's all we need to know. So there's our graph. So let's just draw the graph of f. We did it. All right. Excuse me. This is at what point of C is the domain of f as x approaches C is this. All right. So as you can see, right, this graph is not continuous at x equals 3. By the way, this is an actual hole. You have the limit as x approaches. Well, it says does not exist. So this is just a domain question. So it's just negative infinity to 3 union 3 to infinity. But it would actually be 3 bracket. Because this part from the left side, it includes 3. So bracket. And that part doesn't. All right. But it says where does the limit exist? Never mind. The limit doesn't exist at 3. So it would just be this. All right. Or all real numbers except 3. At what point C is the left hand limit only? So the limit as x approaches 3 from the left of f of x. And so at what point C does only the left hand limit exist? Well, since it's the left hand limit, would be 3. 3 has a left hand limit only. So at C equals 3 for both of these, actually specifically C equals 3, 2. Not C equals 3, 2. At the point 3, 2. And at 3, 1. Because here's a left hand limit. I can get here to C from the left and from the right. From the right, I can get the 3 right here. Oops. So yeah, we do have a left and right hand limit. So what points C? Yeah, I don't like that verbiage. I don't like that. I need to rewrite that. But to clear this up, yes, guys, there's a left hand limit. There's a right hand limit at C. Um, okay, let's move on. Number 13. The function S of t is given, gives the height in meters of an object that's falling from the height of 200 meters. It's just find the velocity. Remember, oh man, you know what? I don't want to go that deep, man. Velocity is just the first derivative. Um, which definition of a derivative? Here's how it looks, guys, for I. All right, you have the limit as h goes to 0. All right, of remember the rule. It says the limit as h goes to 0 of f of x plus h minus f of x all over h. All right, so we'll have negative 4.9 x plus h squared plus 200 minus 4.9 t squared or x squared plus 200. All right, minus all over h. And so remember what I told you, x plus h squared. I know it's really sloppy, sorry. It's always x squared plus 2xh plus h squared. So negative 4.9 times x squared plus 2xh plus h squared plus 200 plus 4.9 x squared minus 200 all over h. Now we simplify this. And this is just a physics problem, guys. Negative 4.9 x squared minus 9.8 x 8. I'm just distributing this plus, no, minus 4.9 h squared plus 4.9, oh, plus 200 plus 4.9 x squared minus 200 all over h. Okay. Couple of things happen. That cancels with that. That cancels with that. So we have negative 9.8 x h. Oh, that canceled. Not that. Minus 4.9 h squared all over h. And then put your limit here. So h goes to 0. We're going to factor out an h so we can cancel out the h at the bottom. You always want to get rid of that h at the bottom. So negative 9.8 h, took out an h, minus 4.9 h all over h, which cancels. Which equals negative 9.8 h. I mean, yeah, negative 9.8 h. 9.8 x, sorry. And now we want to know the velocity at 4 seconds. And you can just leave it like this and be 100% honest. You don't have to simplify these. 4.9 meters per second is your answer. Negative 4.9 times 4 meters per second. If you want to multiply that out, you can. All right, 4.9 times 4 approximately 19.6 meters per second. Negative. All right. For part two, we have to what's the velocity when the object hits the ground? By the way, this is our velocity equation. All right, so we need to first figure out when it hits the ground. So I'm gonna go back to the position function, which is S of t. I want to know when it equals zero, when the height is zero. That's a position, the height. So we go negative equals negative 4.9 t squared plus 200. All right, and so we do some math on that. I'm going to add 4.9 to the other side. So you get 4.9 t squared equals 200. And then divide by 4.9 on both sides. All right, and 200 divided by 4.9, roughly. What do you think about 200 divided by 5? And I'm being generous on this, all right, just for the sake of, um, it's going to be 40 point something. All right, so if it was divided by 5, it would be 40. So I know it's 40 point something. All right, I'm just going to leave it at that value there. And then we square root both sides. Now, I should have, for where we are, I should have put this on the calculator part. Uh, I'll make sure it's nice numbers though for you on the exam. It won't be questions like that. In fact, I know it is nice numbers. When you get a little question like this, it won't be that bad. So this is the value, and so when you want to know the actual answer to part B says when will it hit the ground, the velocity was the velocity. Well, you just go V of this value here. This is negative 9.8 times that. And there you go. Meters per second. That's the velocity when it hits the ground. All right, I told you guys in class, if you were listening, man, you don't have to simplify this. That's the answer. All right, that's the answer. The main thing is that you do the right calculus. All right, but if my memory serves me correct, there is a definition of a derivative problem there. The follow up is not. So this won't be there. This is actually next unit. So I'll get there. But definition of a derivative. Make sure you can do that part. 14, we're just sketching the graph of the limit. So this is actually number 14. I don't know why I renumbered like that, but whatever. The limit as x goes to 0 does not exist, right? Because from both sides, from the left, I'm -1, from the right, I am 0. The limit as x goes to 2. All right, see the purple? Oh, ooh. I don't know if y'all were able to see that on your thing now I think about it. The limit from the left is 0. The limit from the right is also 0. So this would be 0. As I go to 3, I only have a one-sided limit. So this one does not exist. And this one, as I go to -1, it's only a one-sided limit. Man, I didn't even think about that. Just stuff. I'm rusty. I gotta get back in the groove of it. 15. All right. Complete this table. Complete this table. Use the data from the table to approximate the limits as goes to 1. All right. So when you complete the table, and again, I should have put this on the calculator part, guys. This type of table would be on the calculator part. 576. So I apologize about that. All right. You see that the limit approaches 0.577. Rationalize the numerator to find the exact value analytically of the limit. So you have the limit as x goes to 1. All right, as we go to 1. If you plug in 1, you see you'll get undefined, you get 0 at the bottom, and then 1 at the top. You end up with the square root of 3 minus the square root of 3, which is 0. So 0 is 0. We don't want that. All right, so here, I'm just going to put g of x for a second equals 0 to 0. We had to do that just to show it's indeterminate, which is what led us to our next steps. So our limit as x goes to 1, use the conjugate method. All right, so you have 2x plus 1 minus root 3 all over x minus 1 times 2x plus 1 plus root 3. When we multiply it, this radical times this radical becomes the stuff from underneath the radical. This radical times positive is positive. This radical times that's a negative, but notice it's the same thing, so it cancels out. And then you have negative radical 3 times negative radical 3 is a positive 3. Negative 3, sorry, negative 3. Positive times a negative is a negative. My bad. All over this. So now I'm going to simplify. If you need to 4 this out, then yeah, 4 that out so that can make sense to you. You 4 that out. Anyway, you got 2x. 1 minus 3 is negative 2. Which you can factor out a 2. And see, that's going to get rid of that x minus 1 for you right there. Clean this up a little bit. Okay, so now the limit as x goes to 1, that cancels. Right, the x minus 1 cancels out. So we have 2 at the top. And at the bottom, we have this radical plus root 3. And so we plug in now. So I get 2 over, plug in 1. So you get 2 times 1 is 2 plus 1 is 3 plus root 3, right? Because right here, 2 times 1 plus 1, that's 3. So you have radical 3 and then plus this radical 3. Anyway, that's 2 over 1 plus 1 is 2. So 2 radical 3. The radical 3's cancel, the 2's cancel out. So you have 1 over radical 3. And if you know, remember rationalizing radicals, here's how you actually rationalize a radical. You'd multiply both of these like that, and then that's how you get radical 3. And then radical 3 times radical 3 is really radical 9, which is radical 3 over 3. But and to make it simple, I just say move the radical to the top, keep the number from the radical at the bottom. Same thing. All right, this has nothing to do with that problem, so let's move it. Number 16. Number 16 says, and here's the graph. I'm not gonna write it all the way out. Yes I am. Yes I am. All right. Where is this discontinuous? We got a jump right here at 1. So we have a jump at x equals 1. We also have a hole. Oops. We have a hole at x equals 1. And it says identify the type of discontinuity. We just said it, right? We got a hole and a jump. So that's that. Let's see. 17. Find the average rate of change. Remember average rate of change, guys. The average rate of change is f of b minus f of a all over b minus a, or as you know it, y2 minus y1 all over x2 minus x1. So you have the points, the bounds 1, 3. So remember this is x1, this is x2. So f of x1 or f of 1 would be 1 squared minus 2 times 1, which is 1 minus 2. F of 3 would be 3 squared minus 2 times 3, which is 9 minus 6, which is 3. So we'll go 3 minus negative 1 over 3 minus 1. Average rate of change. 3 plus 1 is 4 over 2, which is 2. That's our average rate of change for number 17. Number 18, find the instantaneous rate of change. All right, so remember definition of a derivative. The limit as h goes to 0 of f of x plus h minus f of x all over h. All right, so in this case we have the limit, and our f of x in this case is x squared minus 2x. So the limit as h goes to 0 of x plus h squared minus 2 times x plus h minus the original f of x. Always remember this part right here is always the original f of x. So from here, again, we talked about what x plus h squared equals. X squared plus 2xh plus h squared. Distribute that negative 2. And then distribute the negative. Now, let's see, x squared and the 2x's cancel out. So we have the limit as h goes to 0 of 2xh plus h squared minus 2h all over h, which again, we always factor out that h. Cancel out the h. And so when you plug in 0 for h, you end up with 2x minus 2. All right. Which again, this is our derivative equation or our velocity equation. But it says what's the instantaneous rate of change at 3, so we just want L prime at 3. So 2 times 3 minus 2, 6 minus 2 is 4. So there we go. All right, that's the instantaneous slope at that one point. That's number 18. Number 19 says what conditions, here, let me get it real quick. I'm gonna copy it. All right, anyway, this is number 19, guys. This is wrong, but this is what conditions must be true for a function to be continuous at point C. And the answer is, remember your answer for continuity, the limit as x goes to C of f of x must equal f of C. All right. To go a step further, make sure you know that that's the general limit, which means a limit from both sides. All right. The general limit must exist, which also must equal f of C. All right. This is really number 20, 21, 22, 23. For some reason, it's not cooperating. But right here, we got to find the asymptotes, the holes, and both asymptotes. All right, justify using limits. So um, for this first one right here, we're just gonna factor everything. All right, always just factor everything when in doubt. Um, now, well, here I'm gonna start with the horizontal asymptote because it's the easiest. You don't have to factor anything. Um, top heavy and bottom heavy are the same. All right, it's the same. So y equals 3. Well, our limit equals 3. So horizontal asymptote, y equals 3. For the vertical asymptote, you need to factor the denominator, which you can use synthetic division. So here I'll do that. I'll go, let's pick an x value that works. I'm going to try 5 real quick. And then let me write down my coefficients. So I got 1x cubed, 0x squared, 4x, negative 5. So let's see does 5 work. So 1 times 5 is 5, 0, 5, 5 times 9 is too big. 5 doesn't work. Let me just try smaller. Let's try 1. 1 times 1 is 1, 0 plus 1 is 1, 1 times 1 is 1, 4 plus 1 is 5 times 1 is 5, negative 5 times, negative 5 plus 5, excuse me, 0. So that works. So this right here, guys, is a solution that's x equals 1. That is one of the solutions. And then, well, here, let me show you what it looked like. Like, if you were to factor this out, you have this top all over this bottom. This, that's x minus 1. See, if you move the 1 back over here, subtraction, minus 1 on both sides. Here, let me just show you. Minus 1, minus 1. You get x minus 1 equals 0. So that's where that came from. And then this is your reduced quadratic. So this was cubed. This is now squared. X squared, 1x squared plus 1x plus 5. So this is your vertical asymptote. The top, man, the top doesn't factor, guys. So there are no, the vertical asymptote, x equals 1, and then there are no holes. There are no holes, okay? All right. This next one right here, 1 over x squared minus 3. Very odd one, but there are, let's see, bottom heavy, so your horizontal asymptote y equals 0. And you can show that with the end behavior model, the limit as x goes to plus or minus infinity of f of x equals 0. It's just bottom heavy. Vertical asymptote, we will take the bottom, set it equal to 0, solve it, plus 3, square root both sides. So our vertical asymptote is going to be x equals plus or minus 3. And then there's nothing to cancel, so there are no holes. Let's see here, 2, negative 3. All right, so this is factored. For h of x right here. So vertical asymptote, x equals 1. Holes, there are none. And then if you do end behavior model, there's no horizontal asymptote. I'm not gonna write that out. You know what the end behavior model is. It's top heavy. So no horizontal asymptote. Okay. And then the last one, y equals tangent of x. All right. Tan of x, g of x. Here, let me write it out. There are no horizontal asymptotes. If you just remember what that graph looked like, all the pi halves, there are vertical asymptotes present. All right. So 1 pi half, 2 pi half, 3 pi halves. 3 pi over 2. And so you'll have another one like this. And then another asymptote. And then 5 pi over 2. And then another asymptote. Like that. Alright, so tan x. So vertical asymptote, any x that equals pi over 2 plus pi k. And all this does is just cover every scenario, right? So pi over 2, if you add 1 pi, right, k is just a number, so 1 pi. If you add 1 pi, then you get 5 pi over 2. If you add a half a pi, basically, this is just going to keep you going around the circle. So pi over 2, if you think about a unit circle, right? You have 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2. All right. And it just continues infinitely. And then horizontal asymptote 9. There's also no holes. Okay. All right. Let's see. That is no, we're not there yet. All right, we got to find the slope. All right, let's see. 24 f of x equals x minus 1 cubed. All right, we got to find the slope. So remember to find the slope at x equals 2. That's the instantaneous slope. Whenever you're given one value, all right, find the slope at x equals 2. That's the instantaneous, which means we need the limit as h goes to 0, the difference quotient of x minus h, x plus h, sorry, minus 1 cubed, um, minus the original, all over h. And so this requires some work. So let me just show you how to do it. You won't have one like this on your test, man. You won't. This is, man. Ah. All right, check this out. You won't have one this hard, guys. We need to expand this. I'm gonna show you how to do it the easy way. So this one, I'm gonna omit this one because doing this one algebraically takes a little time. You won't have one that's like this. Man, I gotta rewrite this whole thing, but you won't have one like that. Instead, let me show you one that you will have one like. So I'm going to replace it with something like this. All right, so your question on your test would be actually closer to this one. All right, without all the extra numbers right now, we haven't gotten to where we can do those type of questions yet. So my bad on that. But here we go. Let me show you how this goes. Okay. What you want to first do is find your derivative. All right. So and I'm talking about part B. I'm not talking about this. I don't care about that. So the limit as h goes to 0 of 4 times x plus h cubed. I did it again. Minus 5 times x plus h minus 6. minus the original. So we just subtract the original. So 4x cubed minus 5x minus 6 all over h. All right, this cube, all right, and I don't know if you guys, this is an old school method, Pascal's triangle, um, x plus h times x plus h times x plus h. All right. Again, I don't think I'm giving you a cube, guys, on this exam. But anyway, this is assuming your algebra skills are good. You can FOIL this out 3 times, which means you do 2 of them. Get this right here. And then multiply that by this. So you distribute it again. All right. Or if you know Pascal's triangle, then you can do that. And you'll use these coefficients right here. Anyway, I'm just gonna do it out for you. We have x cubed h to the 0 plus x squared h to the first 3 plus 3x h squared plus x to the 0 h cubed minus 5x plus 5h minus 6 minus 4x cubed plus 5x plus 6 all over h. Let's do some simplifying real quick. All right. So now some stuff should cancel out. That should cancel out with that. That should cancel out with that. And that should cancel out with that. And then we're going to factor all the h's out as well. And when we do that, we get 12x squared plus 5. Or should that be minus 5? That should be minus 5. Sorry about that. Because that's negative 5. Sorry, I messed all that up. There we go. All right, so the question is, what's the instantaneous rate of change? Again, this is our velocity equation or our derivative equation. We want L prime of -2, which is 12 times -2 squared minus 5. So that'll give us 4, 48. 48 minus 5 is 43. All right, so that's the slope. And then back to the other question. I'm just kind of combining them here. Show you how it's done. Find the normal line. For the normal line, well, here, let's find the equation of the tangent line. So y minus y1 equals m times x minus x1. Oh, I didn't find y1, did I? So -2. So f of -2 equals 4 times -2 cubed minus 5 times -2 minus 6. Let's move that over. 8, 32 plus 10 minus 6. 42 minus 6, 36. So we'll come down for our equation of our normal line and go -36 equals 43 times x plus 2, because that's a -2. That's your tangent line. The only difference for your normal line would be, don't change anything but the slope. We want the negative reciprocal. This is our normal line equation. All right. All right, 25. We got to determine the following limits. If they don't exist, explain why. So the limit as we go to 2 from the left. So remember absolute value, guys. Absolute value means there's two sides. There's this one that you see, but there's also this equation right here. Because the absolute value of a negative is also positive. All right, absolute value just means magnitude or distance from the center. So you have both of these. So this is the left where the negative is, and this is the right. All right, again, this is algebra concepts that I just assume you know because you're in calculus. So for the first one, A, when it says, hey, what's the limit as x approaches 2 from the left, you're going to use this equation. And that'll cancel. And I'm left with the limit as x goes to 2 from the left of x plus 2 all over negative. Or it just be -1, so negative. So when you plug in 2 now, you get 2 plus 2 is 4, but you get -4. So that's our limit from the left. For B, all right, we're going to do the right equation. So you have the limit as x approaches 2 from the right. And this one, I'm just going to fatten to the top, x plus 2, x minus 2, all over x minus 2. And when you solve that one, you get the limit as x goes to 2 from the right of x plus 2, which equals 2 plus 2 is 4. And so when you get to C, hey, what's the general limit? And I'm just going to put f of x, since f of x is already defined right here. We're going to put does not exist because the left and the right aren't the same. All right, and that's because of the absolute value. The limit isn't the same from both the left and the right side. All right, 28. Oh wait, let's see. Sketch this graph, guys. Sketch that graph. Practice. Well, yeah. Remember, just use endpoint indicators. As I go to -infinity, I go to a height of 2. So 1, 2. So negative asymptote over here. -infinity. As I go to positive infinity, I go to 0. So positive infinity, 0. As I go to -3, I go to a height of infinity, which that makes -3. 1, 2, 3. -3 is a vertical asymptote. As I go to -3, and that's from both sides. It goes to infinity. As I go to 3 from the Hold on. That's -3. Oh, that's 3. As I go to 3 from the left, I go to negative infinity. So 3 from the left, asymptote. I go to negative infinity. As I go 3 from the right, I go to a height of 2. Which is just that. So your graph should look something like that. True or false, if f is continuous on 1 to 5, if it's continuous on 1 to 5, it has no roots in the interval f of 1 times f of 5 greater than 0, use a graph to justify your answers. So this is true. And think back to what we talked about, the intermediate value theorem. All right, if f is continuous on a to b, all right, then f of a and f of b will have opposite signs, and there's just at least one value c in the interval a to b where f of c equals 0. All right. I'm trying to do this without a contradiction. So, like for example, if you have f of a, if f of a, so look, if f of 1 is positive and f of 5 is positive, then f of 1 times f of 5 is also positive. If f of 1 if f of 1 is negative and f of 5 is also negative, then f of 1 times f of 5 is also positive. All right, so it's two examples because it says it has no roots, meaning there are no x-intercepts. All right, this means no x-intercepts, no zeros or x-intercepts. All right, so that means either they're both above the x-axis or both below the x-axis. In either case, if you multiply them, you're going to get a positive answer. Positive times positive is positive, negative times negative is positive. All right, so this is true. We don't need a graph to justify this. Calculus notation justifies it. Or mathematical notation, excuse me. All right, suppose that f is a function on the domain -5 to 5, and f of -5 is 2, and f of 5 is -2. If the range of f is -2 to 2, must f be continuous? Explain. You may use a graph for this explanation. Again, I think this is another example of the intermediate value theorem. All right, where you have f of -5, f of -5 is 2, and f of 5 is -2. All right, the range from -2 to 2, that can be continuous regardless of how you look at it. All right, the intermediate value theorem states that it's continuous. However, if it is continuous, see, here's the thing: it says it must be continuous. It could be continuous. All right, but there also could be a jump right here, right? Or a hole, right? So we don't have any more to tell me that's continuous. It would be different if it said suppose that it was continuous, then the intermediate value theorem would apply, right? Wholeheartedly. But it didn't tell us it was continuous. So it says, must it be continuous? Well, it would be an assumption that we assume is continuous for everything. And we don't want to assume. We just want to take it for what it is. They never told us it was continuous, so we can't assume it's continuous. All right, it could be continuous. It couldn't be continuous. So therefore, it doesn't have to be continuous. All right, this is a velocity table. It said find the average acceleration, which means just the average rate of change of the velocity. So we'll do 44 minus 20 all over 30. Oh, wait a minute. I'm doing that backwards. Y2 minus Y1. So 38 minus 22 all over 44 minus 20. So 38 minus 22 is 16. 44 minus 20 is going to be 16. Whoa, 26. Sorry, 24. So you got 16 divided by 24. They're both divisible by 4, right? So you say 2/3. And then it would be feet per second squared, feet squared per second. Okay, all this is calculator work right here. So this is really long, so I'm just gonna pause this here. And again, all this is calculator work, so I'm gonna let you guys have it that part.